Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. This is square root of a square minus x square. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. So what I have is a quadratic expression where the coefficient of x is 0, right? I've got a root of a square minus x square, which means I can directly do a trigonometric substitution that will help me simplify y and integrate this, right? So again, drawing your attention to sine square theta plus cos square theta equals 1 and secant square theta minus tan square theta equals 1, right? The substitution which I think will work here is x equals a sine theta. That means my dx equals a cos theta d theta. And when I go back to my y and try and represent everything in terms of theta, what happens to my square root expression? I have integral of square root of a square minus a square sine square theta. So what I have inside the square root is a square minus a square sine square theta, which means that my a square is a common factor. I pull that out and then I have a 1 minus sine square theta, which is a cos square theta. So what is there inside the square root is nothing but an a square cos square theta. And what we will have is a square root of a square cos square theta, which is nothing but a cos theta, right? And then we have our dx, which we have already represented it in the form of theta, which is also a cos theta d theta, right? So what happens is I get an a square cos square theta d theta, right? I know that my a square is a constant, which means that I can pull the a square out of the integral sign. So the way I'm going to write this is y equals a square times integral of cos square theta d theta, right? Now to solve this, you need to be quite familiar with one of the trigonometric identities, and let's come to that shortly. So I have my y is nothing but a square times integral of cos square theta d theta. I'll park my y aside. I'm just going to pick up integral of cos square theta d theta and try and solve this, right? Now, what is that trigonometric identity that will help me solve this further? I know that my cos 2 theta is equal to cos square theta minus sine square theta, right? So my cos 2 theta is nothing but, and let us write this here. So my cos 2 theta is nothing but a cos square theta minus sine square theta. And what happens to my sine square theta here is nothing but I re-express it as 1 minus cos square theta, right? This means that my cos 2 theta is nothing but 2 cos square theta minus 1. I hope you folks are with me. Let me go to the next line. My cos square theta is nothing but a 1 plus cos 2 theta divided by 2, right? So now when I re-express my cos square theta as 1 plus cos 2 theta the whole divided by 2, I'm sure that this is going to make our integration a lot more simpler, right? So what happens is I get integral of cos square theta d theta equals integral of half into 1 plus cos 2 theta, which means I can pull out my half because it's a constant times d theta, right? Now, this is not very complex, right? And the answer to this problem is half times I apply the sum rule of integral. So what happens is integral of d theta becomes theta. Integral of cos 2 theta d theta, what is that? It's a sine 2 theta by 2. So now I have integral of cos square theta d theta, right? Now I go back to my y, a square times, okay. Now take a look at your integral of cos square theta d theta. We have a half outside the integral. So I can multiply the half with a square and rewrite this as a square by 2. A square by 2 times I have a theta plus sine 2 theta by 2 plus c, right? I hope you folks are with me. And then I have my constant c. I cannot leave this answer in terms of theta. We'll have to put back everything in terms of x, and that will again expect you to do a little bit of trigonometric simplification here. So let's do that in the subsequent step. So y becomes equal to a square by 2 times my theta is the first part of the answer. So what is that substitution that we made? The substitution that we made, and let me highlight it out here, is x equals a sine theta, right? So what is your theta? Is nothing but sine inverse of x by a, right? So the first part becomes a sine inverse of x by a. That's my part one. And I come to my part two. What I see is that I have a sine 2 theta divided by 2, because my sine 2 theta is nothing but 2 times sine theta cos theta. And when I divide that by 2, I get a sine theta cos theta, right? And what happens to my sine theta is it's an x by a, right? So I write it as it is. And maybe in order to avoid any confusion for you folks, I think what I'll do is I'll add an interim step out here. So now I'm coming back to the point where we left. Sine theta is nothing but your x by a, and your cos theta is nothing but a square root of 1 minus sine square theta, right? So I'll have to open my square root out here, and then what I get is a 1 minus sine square theta. And what is that? A 1 minus x by a, the whole square, right? I go to the next line and I can express my final answer as follows. We are more or less done. I don't think we can do any major simplification here except for the part inside the square root of this expression. So my first part is sine inverse of x by a, which I write it as it is. And then I come to my second part. What happens is square root of a square minus x square, right? So this will be my answer for y, and I know that I can re-express this in a slightly different way. If I take the a square inside, then what happens to this expression? The first part becomes a square by 2 times sine inverse of x by a, right? That's your part 1. And your part 2, what happens is that the a square gets cancelled, right? And you're left with x by 2 times your square root of a square minus x square, right? So, and then you have your constant. So the answer to this problem is a square by 2 times sine inverse of x by a plus x by 2 times square root of a square minus x square plus your constant c. There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.